Hey everyone, we're going to talk about two important concepts. They're familiar to you, I know, but I'm going to go through them from the beginning. One's called the mean, one's called the median. We've talked about it in class a little bit, but I'm going to formalize. So, what is the mean? It is just the average. You've been doing this since middle school. So, we use the symbol X bar to symbolize the mean. Each element, each number in the list is known as an X, but the average of them, we put a line over the X and we call it X bar. That's a symbol we use for just a sample. If we want to take the mean of a whole population, then we use a different symbol. It's the Greek letter mu. I know it's a funny sounding thing. It sounds like it comes out of a cow. But we'll come back to mu. Today we're just going to stick with X bar because we're going to look at a sample specifically. So, what's the formula for the mean? The mean is calculated by adding up all of the individual numbers, x1, x2, etc., up to xn, and dividing by the total. Now, what are those little 1, 2, and, well, that first 1 right there sort of represents the first number in the list, the second, and you can think of as the last number because there are a total of n things in the list. We add them all up, we divide by n. Nothing new. The fancy way to write it, though, because we are fancy people, is like this, right? And this symbol right here, the sigma that you learned once upon a time, think of it, it's a capital sigma in Greek. Think of it as just adding up. That's how we're going to use it. We're not going to get fancy. Just when you see that, think adding up a bunch of stuff. So we're adding up a bunch of x's, dividing by n, which is the total number of things in the list. All right, let's look at an example. So I did a survey before when school started, and I asked you how many pets you have living in your home. So these are the numbers that you guys gave me. Let's find the average. What do? We just simply say X bar equals the sum of all of these things divided by the number of students in the class, which is 11, and we find that the average number of pets in your homes is 4.27. Who knew? Not very exciting, I know. Not much more to say about that. That should be obvious. Next, let's talk about the median. What is a median? Well, if you literally think of it as the middle number, that's good. That's all you really need to think about. If there's an even number of lists, I know someone in class mentioned this, an even number of numbers in the list, it's the average of the two middle numbers. I'm not going to go into detail about that. Another important thing to keep in mind is half of the data in the list are above the median and the other half are below the median, sort of, right? Because you're not including that actual number, but whatever. Now, it's important when we're finding the median to put the numbers in order from least to greatest. They have to be in order, otherwise the median will have no meaning. So once they're in order from smallest to largest, we start chopping off from either end at the same time. We cross off the first and the last, the second and the second to last, etc., and so on, until we arrive at a single middle number, and that we define as the median. You can just write MED for short. Nothing too earth-shattering there. Now, here's where it becomes a little more interesting. What do these two numbers look like on a dot plot? As you see, I plotted all of the numbers of pets on here. You'll see that most people have either 0, 1, or 2 pets. One person had 12, one person had 27. Now, where is the median in this list? Well, we found out that the median was 1, right? And there it is. Where is the mean? Well, the mean we found was 4.27. And there it is. Okay. Notice the median and the mean are quite far away from each other. And the reason is because there's a lot of skewness. This is very skewed to the right. The important thing I want to point out about this picture is the median is sort of, you're right, it's the, half of the dots are on the left, half the dots are on the right, sort of. But the mean, what does the mean represent? Well, I want you to think of the mean on a dot plot as the balancing point. Now, I know you might be thinking, Mr. Froyman, how are we balancing 9 dots on the left and 2 dots on the right? Well, those dots are really far out to the right over here, Oops. So they, if you ever took physics, they're kind of like, heavier sort of because they're further out, like kind of when you were on a seesaw and you sat all the way on the end to make yourself heavier. So the mean is literally the balancing point. Okay, now here comes the $1 million question. Suppose it turns out that the person who typed 27 did a typo. They don't really have 27 pets. Who has 27 pets? They really meant to type just 2, right? So that dot should be over here. And now my question to you, and I want you to pause the video for a second, is where is the mean and where is the median now? Okay. So we moved that 27 to 2, where it theoretically might be. Instead, where is the new mean? Where is the new median? So pause the video. Okay, here comes the big surprise. The median hasn't moved, right? The median is still 1. Half the numbers are less than 1 and half the numbers are above 1. Where's the new mean? Surprise, not at 4.27. The actual mean of all of this data is just 2. That is the new balancing point. What is the moral of the story? The following. The mean and the median differ in an important way. And this is critical. The median is resistant to outliers. Okay? That means the median doesn't really get affected with numbers that are really far away. Once we moved the 27 and made it a 2, it was the same median. I could have taken that 27 and made it a million. The median would still have been the same. It would have been a 1. Sorry. I may have misspoke a second ago. The mean, however, is not resistant to outliers. The mean changes when you have extreme values, as we just saw. Okay? Very important concept. Okay, last thing I'm going to show you. So we might see data that looks kind of in 3 varieties. One, we might have data that is skewed to the left. And you'll notice that when data is skewed to the left, the median is to the right of the mean. The median is to the right of the mean. That's because the mean is affected by those outliers, by that 13 and 14. Okay. Another scenario is if we're skewed to the right, you'll notice that in this case, the mean is to the right of the median. Why? Because of all of those numbers on the right are kind of affecting the mean and pulling it to the right, whereas the median is unchanged. I know this is weird data. I know the first picture is quiz scores. The next is goals scored in a soccer game. I'm going to show you one more set of data where the mean and the median are at the same place. Why? Because we're symmetric. It doesn't mean they're going to be in exactly the same place. But if you're symmetric, they're going to be pretty much in the same place. Now, here's the bonus question, and the last question I'm going to ask. Why is some data skewed and some data symmetric? Okay. The answer is because of natural cutoffs. What do I mean by that? We have, if you look at the first set of data, the quiz scores, what's the highest score you can get on this quiz? It's a 20. That's a natural cutoff. That's why we're not going to get stuff on the right. We can go far to the left, but we're not going to go to the right of 20. So because there's that natural cutoff, at 20, you're skewed to the left. Soccer goals. There's a natural cutoff at 0. You cannot score negative goals in a soccer game. You can only score positive. What's the most you can score? There is no most. It can go very far out to the right. And that's why the data can be skewed to the right when there's a natural 0. Now, if you look at the highway fuel economy, technically you can't get less than 0 miles per gallon or more than a gazillion miles per gallon, right? So yeah, technically there are cutoffs, but in reality, we're so far away from those cutoffs, it doesn't impact our data, and that's why we're symmetric, right? So the mean and the median, we kind of expect to be in the same place. Anyway, I hope that was helpful. Yeah, feel free to ask me any questions. Enjoy the next video.